lesson we learned that in a different base system, the highest digit of that system is one smaller than the base. So in this first problem, we're working in base 5. So the highest digit is 4. So what we're going to do is set up the arithmetic problem, just what we would set up arithmetic problems in elementary school. Or when we add, it's easiest to add right on top of each other. But we're going to have to do carrying, like we did in elementary school, but we have to carry faster than we did in elementary. In elementary, we had to carry once we got to like 10s or anything higher than a 9 is when we had to carry over. Now, depending on what our base is, that's when we're going to have to start carrying over. So in a base 5 system, we can only write a number as big as a 4. If we go any bigger than 4, we have to start carrying over. So when I add 2 plus 3, I get 5, but I can't write 5. So what we do then is that is the same as writing a 10. We have to carry over. Okay. At the top of the notes on the other page, we said that like counting in base 5 is going 1, 2, 3, 4, 10. Okay, so that's what happened here. When we add it up, we can't get a 5, so it's like we're starting over into the next set of numbers, and we get a 10. So now when I add up the next one, I get 1 plus 4 plus 2, which is 7. Okay, we don't have a symbol for 7, so what we have to do is think about, well, how many 5s are in 7? 1 5 with how many leftovers? 2. So we're carrying over the 5s and then writing the leftovers down at the bottom. So then now when I add 1, 3, and 2, I get 6, but I can't write a 6. So how many 5s are there? 1 with how many left over? 1. So 1, 1. And we put the little 5 down there to show that this is still in base 5. Okay, so it's the same idea as carrying in elementary school. It's just that we have to carry a lot sooner than we used to have to carry because we can't go all the way up to 9. We can only go up to whatever the base is. So in adding a binary, if the base is 2, the biggest number we can write is 1. The biggest number that exists in a system is one smaller than what the base is, the biggest digit. So 1 plus 0 is 1, and I can write a 1. 1 plus 1 is 2, but I can't write a 2, so I have to do a 1 with 0 left over. A 2 has 1 2 with none left over. Now when I add up 1, 1, 1, I get 3, but I can't write a 3, so how many 2's are there in 3? 1, so we carry over 1 with how many left over? 1. 1 plus 0, 1, and then just carry down that last one. Now when we work in hexadecimal, it's hard for me to always remember what the letters match with kind of our numbers. So I'm just going to set up a chart. 3 is 3 all the way up to, I don't struggle with that. But once I get to 10, 10 is A, 11 B, 12 C, 13 is D, 14 is E, and 15 is F. So then when I write out this number, what I'm going to write out is 1, 3, 5, and then E is really a 14. And I'm going to put it in parentheses to show that that's like one thing together there, that it's not like a 1, 4, it's a 14. And then 2, 1, and C is 12. So in base 16, our biggest digit is 15. So we can't write anything bigger than a 15, and then we would have to think about carrying it. So if I add 14 and 12, I get 26. That's bigger than a 15. How many 15s are in 26? 1, with how much left over? 11. Again, I'm kind of group that up so I remember that's an 11 and not a 1, 1. So adding up, I got 26, 26 is 11 more than a 15, so I carry the 15 and I've got 11 left. 151 is 7, and that's not a problem. 32 is 5 and 1. But then in our final answer, we don't really have that symbol for an 11, so we need to change that 11 into a B. You know what? Did I do that right? I did that wrong. On this 11. Everything's good except for the one. Okay, so on, I think I asked how many 15s are in it, but I don't really actually care how many 15s are in it because we're on base 16. So it added up to 26. So how many 16s are in it? 1 with how much left over? 10. Oops. So this should actually be a 10. That an A. Sorry about that. Our base symbol is 15, but we actually care about 16s since we're working in base 16. Okay, so that's addition. So addition, we just need to think about carrying over any time that we get to a symbol bigger than what we have. Subtraction. Subtraction, we can subtract as normal until we would need to borrow. And then we need to think about borrowing like we did in elementary school, except in elementary school we were always borrowing 10s because we work in a base of 10. So in this system, we're going to borrow however many of whatever kind of base we have. So first I can do 4 minus 3 and I just get 1 and that's fine. But I can't do 2 minus 4. So now I need to borrow. So I'm going to borrow from that 4 and make it a 3. But I'm not going to borrow 10 like we always did in elementary school and make it into a 12. Since this is base 5, I'm going to borrow 5. So this 2 is going to become a 7. Okay? So in elementary school when we borrowed, we were always borrowing a group of 10 away from the thing in front of it. But whatever base we have, we're borrowing that many from the group in front of it. So we're borrowing 5 from the group in front. So 5 and the 2 makes that now a 7. Instead of like a 12 like it would have been in our normal system. So 7 minus 4 now is 3, and 3 minus 1 is 2. Questions on any of the 4 of those before I scroll, because they'll disappear when I scroll. Okay, so another subtraction problem. So 632, 256, and this time we're working in base 8. So 2 minus 6 I can't do, so I need to borrow. When we borrow, we're going to borrow one group from the thing in front of it, so the 3 is going to become a 2. And the group that we're borrowing is whatever the base is, and the base is 8. So we're borrowing 8 units from there. So that now makes 10. Now 10 minus 6 is 4. 2 minus 5 I can't do, so I have to borrow. The 6 becomes a 5, and we're borrowing a group of 8, so now that 2 becomes a 10. 10 minus 5 is 5, and 5 minus 2 is 3, and our base is 8. When I write out the hexadecimal numbers, again, I like to write out what the number actually is in parentheses instead of writing out what the letters are, because I have trouble keeping track of what the letters are supposed to be. So A is supposed to be a 10, and B is supposed to be an 11. E is a 14. So 11 minus 4 we can do is 7. 10 minus 14 we cannot do. So we're going to borrow a group, so the 7 becomes a 6. And the group that we borrowed is whatever the base is, so 16. So we borrowed 16 to take into that next spot. So that 10 is now a 26. 26 minus 14 is 12, and I'm going to put parentheses around there, so remember that's a 12 and not a 1, 2. And then 6 minus 3 is 3. Then our final answer, we don't want those 2-digit figures. We want to turn them back into their letters. So that's 3C7, base 16. Questions on subtraction? Multiplication is really a lot like addition. Multiplication really is just repeated addition. We're adding over and over. We're going to multiply in the same format as we did in elementary school. I hope most of you learned how to multiply kind of in this format. I know it's becoming more and more popular as you guys were going through school for teachers to use like that lattice system, which is a really cool thing, but I have no clue how to do it. So I can't help you with that. If that's your system, I don't know how to turn lattice into this because I don't know how to do the lattice thing. But what we're going to do is start with that bottom 3, that very last number. We're going to multiply 3 to the top. So 3 times 4 is 12, but we can't do 12 because this is base 5. So what we have to do is think about, if my answer is 12, how many 5s are there in a 12? 2. So that's what we have to carry with how many left over? 2. Okay. So it's really tempting here for students to just have the 1 up top that we're kind of carrying over, but the answer isn't 12 because there's no such thing as 12. There's 2 5s and 2 leftovers. So then we multiply 3 times 1, we get 3, plus those 2 that we carried over, so that's 5, and we don't have 5s, so we have a 1 to carry over with 0 left over. 5 goes into 5 once with no leftovers. Then now the 3 times the 3, which is 9, and 1 more makes 10, but we don't have 10. 10 is 2 5s with no leftovers. Now I'm going to go through and multiply the 2 times everything on the top, and I'm going to change my writing color so that when I carry, I'll be able to tell what my new carries are as opposed to what my old carries were. So now I'm going to multiply that 2 times the 4. 2 times 4 is 8, but we don't have 8, so 8 is how many 5s? 1, with how many leftovers? 3. And that gets inset by 1 step as we do that second one. Then 2 times 1 is 2, with 1 more is 3, and that's fine. We can do a 3. And then 2 times 3 is 6, but we can't do 6. 6 is 1 5 with 1 left over. And then we want to add them up. And again, if we need to carry it all, we might need to do that here. So 2, 3, 3, 3, 1. So we didn't need to carry over it all, but you might need to, just like we did the adding stuff earlier, you might need to carry over. Multiplying in binary is kind of nice because all you're ever multiplying by is a 1 or a 0, and a 1 is a 1, and a 0 is a 0. So the multiplying goes pretty quick, but then we'll have to be careful when we start adding that we're going to have to do some carrying over most likely. So starting with the very bottom right-hand 1, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. We just get that top number back again. Then going to the next one and multiplying it through the top. 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. So we get the same thing, it's just inset. Now we need to add, but we're going to have to be careful about carrying. So that first one we can just bring down. But now 1 plus 1 is 2, and we can't write a 2. So a 2 is 1, 1 with 1 left over. Sorry, 1, 2 with 1 left over. No, 0 left over. Sorry. And a 1 plus a 1 is 2. We can't write 2. 2 is 1, 2 with nothing left over. Again, 1 and 1 is 2, which is 1, 2 with nothing left over. And again, 1 and 1 is 1, 2 with nothing left over. Okay. So it's the same rules as arithmetic that you learned a long time ago, but maybe are kind of dusty because we love our calculators. But the same rules in terms of carrying and borrowing, we just need to be careful about how many we're carrying and borrowing. We're carrying and borrowing the amount of whatever the base is.